Hello, welcome to another webinar in our International Approvals and Market Access webinar series. This is our last webinar of the year. My name is Sherwin. I'm an Approvals Manager here at Vista Compliance Laboratories, and today our topic will be regarding FCC in the United States. We'll be going over RF exposure requirements, specifically specific absorption rate, or SAR. Every electronic and wireless product needs to go through wireless testing and certification. Part of that is RF exposure evaluation. So that's the impact that this product has on the environment and the human body. So today we'll be talking about the requirements set forth by FCC regarding RF exposure, specifically working our way to SAR, which is specific absorption rate for products that are used in close proximity with the human body. What is the FCC? In a previous webinar, we did mention basics of FCC and United States compliance for wireless telecommunications products, but we'll be touching on this again briefly right now. So the FCC, Federal Communications Commission, regulates international communications by radio, wireless, satellite cable in all 50 states. It's an independent U.S. government agency, and they're responsible for enforcing the America's communication laws and regulations. There's different departments, but in general, radio frequency devices are required to be properly authorized under FCC rules before marketing or import to the United States. So the OET, Office of Engineering Technology, administers the EAP, which is the Equipment Authorization Program, and they also develop rules regarding requirements, etc. But this is how we ensure that all RF devices used in the U.S. can operate effectively without causing harmful interference. So we'll be touching on RF exposure, which is part 2 of the Commission's rules, where they set out the requirements for harmful interference and RF exposure. So all RF devices must be subject to equipment authorization before import or sale, and must comply with the requirements set forth by FCC. So as I just briefly mentioned, FCC sets forth the regulations. This is in Title 47 Code of Federal Regulations. There's many rule parts and subparts. This is a non-exhaustive list of some rule parts that set forth the limits for wireless communication devices. So how does this relate to SAR? So these rule parts contain the limits for safe exposure to RF energy. These limits are given in terms of a unit referred to as specific absorption rate, SAR, which is a measure of the radio frequency energy absorbed by the body, for example, when you're using a cell phone. So FCC requires that cell phone manufacturers, they need to ensure that their phones comply with these limits set forth in these rule parts for safe exposure. So any cell phone below the SAR levels would be a phone that can legally be sold, and it's safe, measured by these standards, and anything that's over that would be considered unsafe and not allowed to be sold. So we'll primarily be looking at part 2. So that contains the RF radiation exposure evaluation requirements and limits for mobile devices and portable devices, which is something we'll expand on later. Moving on, we'll be going over some basics about what is SAR. So we know that the FCC sets forth various rules and requirements for RF exposure through their regulations and rule parts. But now let's take a look at some of the concepts regarding RF exposure. RF exposure measurements or calculations is what we use to determine whether transmitters or devices comply with the limits adopted by the FCC. So SAR is a measure of a rate that the body absorbs energy when exposed to RF electromagnetic fields, or EMFs. So this value corresponds to the energy absorbed, for example, by the head of a user when using a smartphone. These values is what determines, we compare that with the limits and see basically if this product is in compliance with the regulations set forth by the FCC. So this is a number defined as the power absorbed per mass of human tissue. So when we're doing the testing, we're simulating if this was a real person, how much power would they be absorbing through the EMF fields generated by this wireless device. And it's given in the units of watts per kilogram. So it's usually averaged over the whole body or over a small sample of tissue, typically 1 gram or 10 grams. And this number is noted in the FCC grant and equipment authorization. So this value is public, so your consumers will know what the SAR value is. The RF exposure guidelines are based on SAR and MP limits. So here we have MPE and SAR. So the guidelines are based on the limits for MPE and SAR. The very basic restrictions for human exposure is based on SAR limits. So at the very core, the limits are defined by the SAR limits, but MP limits are derived from the SAR limits in terms of field strength and power density. So basically, it's based on SAR, but MP limits are more relaxed. So MP limits apply to transmitters operating in the frequency 300 kilohertz to 100 gigahertz, and SAR compliance is we use SAR limits for up to 6 gigahertz. So yeah, SAR compliance is between I think 100 kilohertz to 6 gigahertz. So for devices that operate at larger distances, we use MP limits. So RF exposure is very dependent on distance of the EUT from the human body, which is defined by the manufacturer. So if it's used at a closer distance, then we need to consider SAR limits, and a further distance we can use MP limits. So if we can avoid more complex SAR evaluation, basically if the devices are used further from and they operate further from people. So we just briefly talked about MPE, which is maximum permissible exposure. So these limits apply to all FCC regulated devices in all exposure conditions. So there's different conditions such as a fixed exposure or a mobile exposure, depending on how far the product is and how it's intended to operate. But here's a list of rule parts where a routine RF exposure evaluation is mandatory for equipment, which means basically for portable devices, including SAR measurement. These are the things that these are the rule parts where the SAR measurement may be required to show compliance for the different operating configurations of the device, different exposure conditions to the device, different accessories that the device may come with. And here is a list of different measurement procedures for radio frequency exposure. So these are more product-specific procedures. So when making measurements to demonstrate compliance with the FCC's rules that they set forth, we need to use the appropriate measurement methods. And this can be defined in a section of the rules or in some guidance that the FCC puts out. So these documents listed here are prepared by the FCC and are intended to provide some sort of guidance on measurements and procedure for RF exposure. There's other measurement procedures that can be accepted, but these have been found to be acceptable by FCC for compliance testing, and they often update these documents or provide new documents to provide more information on procedures and guidance on how to test devices subject to their rules. So previously we touched on how the distance the device is from a human body greatly affects RF exposure calculations and measurements. So obviously if a device was intended to be used much closer to your body, then you would receive more exposure versus if it was further from your body. So here are the different operating conditions. Fixed installation. So this term means a device that is physically secured at one location and not easily able to be moved or transported to another location. So this when I mean separation distance from the human body, we are talking about the antenna, or basically the radiating structure of the device. So for example, if a device is outside, like a base station, you would get exposure in a far field condition. So your whole body would get exposure, but it would be in a far field condition. So in that case, we use MP evaluation. And for mobile devices, it's basically a device that's intended to be used at least 20 centimeters away from the human body. So it's not a fixed location, but it's used in a way that it generally a separation distance of at least 20 centimeters is between the human body or any nearby person and the radiating structure of the transmitter. So, for example, the antenna. So this can be on a non-permanently fixed object. So this can be on like mounted on a vehicle, etc. But you must specify the distance at which safe operation is permitted. So moving on to portable devices. So this is so mobile devices, you would think like a smartphone, but actually a smartphone would be considered a portable device under the FCC's definition. So portable devices are transmitters that are used within 20 centimeters of the human body. So the radiating structure of the device is normally within 20 centimeters of the human body. And this is when we would use the SAR measurement if required, or do calculations as per the SAR limits. So these products would be used in a near field condition and you'd get more localized exposure. So we would have to see if the product qualifies for SAR exclusion based on the SAR thresholds, or if not, then we need to do SAR measurement and evaluation. So again, SAR limits, so MP limits are derived from SAR limits. So SAR tends to be the more strict and the more restrictive limit. So if it meets SAR limits, then it should also meet MP limits. So again, fixed installation and mobile devices. Don't confuse mobile devices with like a mobile phone or a smartphone, but these two will follow MP limits, and portable devices use less than 20 centimeters from the human body will require SAR limits. The next concept we should be familiar with is exposure conditions. So the previous slide we talked about operating conditions of the EUT or the device. So now we're talking about the exposure conditions of the human body. So the two are occupational and controlled, or general and uncontrolled. So occupational controlled means that it's work related. The person the person is aware of the exposure, and they have information regarding how to control the exposure from the device, how to limit it, and this may require RF exposure training. And then for general and uncontrolled, it's basically all of the situations where typically applies to consumer devices where you don't have any knowledge of the exposure. In that case, there's more restrictive limits. So this is just here to explain that depending on your intended use case, you may have slightly more relaxed exposure limits if it's an occupational or controlled exposure condition for the product, or if it's general and uncontrolled. So these are the MP limits for controlled exposure. This table is basically the criteria we use to evaluate the environmental impact of human exposure to radio frequency. These limits are based on what is called source-based time averaged maximum conducted output power. Basically, it's the worst case output power of the RF channel requiring the evaluation. So when we do the testing, we need to test multiple channels, and some of that can be reduced, but in general, we test multiple channels, and every channel must comply. This is adjusted for tune-up tolerance. So depending on the tune-up tolerance, it can be much even worse case output power. So and also this is based on minimum test separation distance. So we need to consider the worst case test separation distance, which is the distance from the radiating structure of the device and the human body. And again, these limits apply to both fixed and mobile exposure conditions. Okay, so that was for occupational and controlled exposure. Now we'll take a look at the limits and requirements for uncontrolled exposure. So here are the limits for uncontrolled exposure for general populations. It's a very similar table. The only difference is that the limits are tighter. Going over some of the things in the table, actually, frequency range is in megahertz. and we usually compare it to the power density. So 1.5 gigahertz to 100 gigahertz, the value is 1. And again, this is a maximum conducting output power and is time average. So for uncontrolled, it's average over 30 minutes, and previously for controlled, it was average over 6 minutes. Again, it's adjusted for tune-up tolerance for worst case. So just to summarize, occupational and controlled basically means that the exposure is controlled, and it can be a result of someone's work environment, versus general and uncontrolled. It's not employment related. It's just anyone can come near the vicinity of this wireless transmitter. So it has more strict limits. So this is the formula we use for a maximum permissible exposure calculation, and again, this applies for fixed and mobile transmitters used greater than or equal to 20 centimeters from the human body, and operating in the frequency spectrum 300 kilohertz to 100 gigahertz. So S here is the power density, P is the power input to the antenna. So it would be a conducted if you measured. If you did a conductive measurement on the antenna port, that would be what the value of P is. And then G is the gain of the antenna. This is antenna gain in a linear scale. And R is the distance to the center of the radiation antenna, so the separation distance. For example, 20 centimeters. Taking a look at a sample calculation here, basically if you have a product that has output power of 1000 milliwatts or 1 watt. So that would be a conducted measurement of 30 dBm. And the antenna, suppose it is 0 dBi antenna gain. So on a linear scale, that would be 10 to the power of 0 over 10, which would be 1. So 1000 times 1 divided by 4 pi times the separation distance, which we say, for example, 20 centimeters. So if it's intended to be used 20 centimeters from the human body, so 20 squared, that would give you a result of the power density being 0.198. So previously on the table, for that frequency range, 1.5 gigahertz to 100 gigahertz, the power density was, the limit was 1. So 0.198 would be less than 1. So here it's clearly passing. So this is for the 20 meter separation distance. So as we know, anything closer than 20 centimeters, we would need to do a specific absorption rate evaluation. So that covers it for some of the fundamentals for maximum permissible exposure and the key concepts on when it applies and how to calculate it. And moving on, we'll be going over the similar requirements and procedures for a specific absorption rate. So the exposure conditions for SAR is a little different than MPE. There's 4 different cases, so head exposure, body exposure, extremity exposure, and if a transmitter is implanted within the body. So starting with head exposure, procedures vary depending on the location of the antenna in the device. We test in a configuration that represents the worst case and how the device would normally be used and operated. For body exposure, we need to define the test separation distance. So basically for devices worn on the body, usually there's like a body worn accessory. If this accessory contains metallic components, then we do the testing with the accessory. This device as a system would demonstrate compliance. And for the separation distance, this distance is defined by the manufacturer according to how the device may generally be worn. The rule of thumb is it's not usually more than 2.5 centimeters from the human body. So all body-worn accessories must be disclosed to the user through the user guide or manual. So then, like, unsupported accessories are not used. This ensures that like the device as a whole would still comply with RF exposure limits. So extremity exposure is for devices intended to be used on extremities and mainly operated in extremity only conditions. So like a mobile device, like a smartphone, would not fall under this category because it's not primarily intended to be used only on your extremities. And extremities would be like your hands, wrists, feet, and ankles. So in this situation, extremity SAR evaluation may be required. Lastly, transmitter implants. So the rule of thumb is these can be excluded if the output power, and this would be the worst case maximum output power, would be less than or equal to 1 milliwatt. And then going back to extremity SAR measurements, these may require an inquiry with the FCC. This would clarify like the process and what procedures to use for these special products. So this is the test exclusion criteria. So basically, SAR evaluation for if this criteria is met, then SAR evaluation for general population exposure conditions by measurement is not required. So we have the maximum power of the channel divided by the minimum test separation distance multiplied by the operating frequency, square root of the operating frequency. And if this value is less than or equal to 3, this is for 1 gram SAR, so per 1 gram of human tissue, then SAR measurement is not required. And for 10 gram extremity SAR, the value is 7.5. The max power of the channel is adjusted to include tune-up tolerance, and the value is in milliwatts. Test separation distance is in millimeters. Usually this test separation distance is determined by, as I mentioned before, the smallest distance from the antenna and radiating structures from the human body. And F is frequency in gigahertz, so transmit channel frequency in gigahertz. Taking a look at a simple sample calculation, so if you have a product where the maximum peak conducted output power, which is usually measured in dBm, is 9 dBm, then convert to milliwatts is 8 milliwatts. So using a minimum separation distance of 5 millimeters and an operating frequency of 2.4 gigahertz, you have a value of 2.48. But if that product was just 1 dBm higher, so if it was 10 dBm, that would be 10 milliwatts, and using the same test separation distance, you would have a value of 3.1, which would be exceeding the SAR limit. So this is obviously a simplified example, and it's not accounting for any different tune-up tolerances or any different frequencies, but this example just shows that small variations, the variation in the dB can change the output power greatly and can affect the SAR calculation. So this is a summarized table for the thresholds for SAR exclusion. This is for the frequencies between 100 megahertz and 6 gigahertz with test separation distance less than or equal to 15 millimeters. So these aren't limits. So these aren't like the limits for SAR. These are the thresholds for exclusion of SAR measurements. So you have your frequencies on the left. This is not a complete table. So, and then this is just a summary, so you can still calculate it using the formula we just did. And then that the millimeters, the red row would be the distance, separation distance, and the numbers in the table are the thresholds. So, although SAR is determined at the highest certified power level in lab conditions, actual SAR levels for example, smartphones nowadays, it can be actually well below this number, and it's because usually cellular phones are designed to use the minimum power required to reach the network. So actually, if you're actually closer to a base station, for example, it's more likely that the SAR value would actually be lower. So these are the exposure limits. So these are the actual limits for SAR. And again, SAR is the basic fundamental reference exposure limit. So MPE, which we spoke about before, field strength and power density limits are derived from SAR. So MPE is derived from SAR, and MPE limits have additional margins in them to ensure compliance with the SAR requirements. SAR needs to be evaluated using special tissue liquid or tissue medium. here are the limits. So for occupational and controlled exposure, you can see that the limits are much more relaxed than for general population and uncontrolled exposure. So whole body, meaning your whole body is exposed. So basically, it's averaged over your whole body versus partial body or extremities. So so partial body means it's averaged over 1 gram of tissue, and this would be like in the shape of a cube. And then the extremities would be for your hands, wrists, etc., averaged over 10 grams of tissue in the shape of a cube. So our limits, again, are not applicable above 6 gigahertz. So that's when MPE limits for field strength and power density are applied. So what happens if you have multiple antennas transmitting at the same time? So SAR measurements are frequency dependent, we know that. This is due to various factors such as the probes that we use, or the tissue medium, the dielectric parameters of the tissue medium that we use. Simultaneous transmission at multiple frequencies will require SAR to be evaluated independently for each frequency using the appropriate calibration tissue dielectric parameters in identical device positioning conditions. Simultaneous transmission SAR test exclusion is determined for each operating configuration and exposure condition according to the SAR values reported for each applicable simultaneously transmitting antenna. So for each antenna, we need to know the SAR value, and when the sum of the 1 gram or 10 gram SAR, depending on whether it's partial body or extremity, the sum of all the transmitting antennas simultaneously transmitting in operating mode and exposure condition, if that value is within the SAR limits, then the SAR test exclusion applies for that particular simultaneous transmission configuration. So the FCC also has some test reduction criteria. So SAR test reduction procedures may be applied, reducing the amount of tests needed for similar transmission modes. So although there's various things that can happen regarding variations in implementation and design and requirements of different transmission modes and different configurations, generally this would result in different SAR distribution and RF exposure characteristics, but testing of other required channels within a certain operation mode of a frequency band is not required when the following conditions are met for 1 gram and 10 gram SAR. This is for the mid-band and highest output power channel. So for the transmission band less than or equal to 100 megahertz, for 1 gram and 10 gram SAR, if it's lower than 0.8 and or 2.0 watts per kg, and for the transmission band 100 to 200 megahertz, 0.6 and 1.5 watts kg for 1 gram and 10 gram SAR. And greater than 200 megahertz for the transmission, we would have it would have to be lower than 0.4 and 1 watts per kilogram for 1 gram and 10 gram SAR. So if any of these are met, then testing of other channels within the same frequency band operating mode is not required. So next we'll be touching on the topic of radio modules. So if a radio module was approved by FCC and you want to put it in a product, what are the restrictions on that? So there would be no restriction if the values of the SAR test exclusion are met. So in that case, no SAR testing is required. Additionally, it would have to meet the requirement of lower than 0.4 watts per kg measured for 1 gram SAR. So for and then this was for a separation distance of 5 millimeters. This is applied for the test exclusion per the exclusion requirements, but basically separation distance of 5 millimeters would be used. For a radio module to be restricted to multiple hosts or a single host, the requirements are 0.8 watts per kg or 2.0 watts per kg for 1 gram and 10 gram SAR for multiple hosts. So this would mean that the module or peripheral transmitter may be approved to operate in multiple host platforms and approved for using different hosts. This would have to be done. So basically the module itself must have been approved already in the initial FCC filing to be used in a multiple host platform condition. Otherwise, you would need to do a Class 2 permissive change, and you do have to do some testing in that case to see if it would be qualified to use in a multiple host platform. And then for a single host platform, meaning that the radio module can be restricted to using integrated into a single host, the limit would be 0.6 watts per kg or 1.5 watts per kilogram for 1 gram and 10 gram SAR. This means that the equipment approval obviously is limited to a single host platform. So we'll look at the measurement system. There's a positioner with a probe attached which scans the tissue liquid in the phantom. So that's a SAM phantom, which is specific anthropomorphic mannequin, which is filled with tissue liquid, and then underneath that is a device holder which holds the device that can be adjusted for separation distance. And again, the liquid in the SAM phantom is a special dielectric liquid, equivalent of the human tissue. So there's multiple test configurations required for SAR testing. Usually we test the low, middle, and high channels, and for example, handsets, smartphones, we use the left side and the right side of the SAM phantom, which is the one that looks like a human mannequin, and then also in cheek touching positions and different tilts. So tests are repeated for all operating modes and frequency bands unless there's test reductions that can apply. And then other configurations are generally tested also on low, middle, and high channels with the device positioned at appropriate distances away from a flat phantom. So this would be just a phantom containing liquid that's completely flat. That would represent, for example, a human body. So for the actual procedures of the SAR measurement scan, so we have an area scan we use to determine the peak SAR locations. In this case, the scan area should be larger than the region projected by the device onto the phantom to capture all of the different peaks. So peaks should be anything found within 2 dB of the highest peak are evaluated using a zoom scan afterwards to compute the highest 1 gram SAR measurement value. The zoom scan should be centered at the peak SAR locations, and this is used to determine this from the area scan, which we use to determine the final 1 gram average SAR value. The zoom scan should also be extending like 1.5 times larger than the dimension of the 1 gram or 10 gram cube in each direction. So that was some of the basics for the SAR requirements. Again, SAR's compliance is determined using tissue equivalent media between 100 kilohertz to 6 gigahertz. So for devices that operate at larger distances, where there's minimal RF interactions between the device and a user or any nearby people, then we can avoid the more complex SAR evaluations, and we can evaluate as per the RF exposure compliance using maximum permissible exposure limits. Thank you for tuning into our webinar today. I hope this was informative and useful to you. SAR testing can be quite time consuming and complicated, so we can work with you to find out what requirements apply, exclusions, criteria, etc. There's different test methods we use for calculating and measuring RF exposure, as well as for performing RF exposure measurements and tests. So definitely reach out if you have any further questions regarding your product or your situation. So definitely let us know. You can send us an email at info@vista-compliance.com. Vista Compliance Labs is a 17025 accredited test lab and FCC recognized. We're also recognized by other countries all over the globe, and we can provide global market access as well as certification services for different countries all over the globe. So if you have any questions, reach out. And again, this doesn't cover everything. There's also hearing aid compatibility, which sometimes goes hand in hand with SAR. So there's other concepts that we didn't touch on today, product-specific measurement procedures that we didn't touch on today. So hopefully this was still a good intro and provided informative information for you to get started with SAR compliance. So if you have any questions, reach out, and I hope you enjoyed the last webinar of the year, and we'll be back next year for more information for you. So thank you and have a nice day. Bye-bye.